So today we will be working on trigonometric identities. In this problem, the left side is more complicated, so we'll start there by separating the sines and cosines. They share a common denominator of sine, so we can combine them. A common mistake at this point is to try to set it equal to the right side and cross multiply, but that is not allowed. We cannot do that. So instead, we will take the denominator of the desired result and multiply the numerator and denominator by it so that it's the equivalent of multiplying it by 1, so that's okay. Then we'll multiply the numerator and not the denominator. So you get 1 minus cos squared, which is equal to sine squared in the trig identity. And sines cancel, and you get your answer. In this problem, the left side is once again more complicated. So we'll create a common denominator by multiplying 1 by 1 plus sine over 1 plus sine. Then we'll combine those and rearrange so that we can see that we have a 1 minus cos squared, which is equal to sine squared, as previously mentioned, as a trig identity. We can take out a sine, creating a 1 plus sign in the numerator, which can be canceled with a 1 plus sign in the denominator. And that's your answer. In this problem, we will once again be creating a common denominator by multiplying each part by the other's denominator in the numerator and denominator. So we will multiply those together, and so we have cos squared plus 1 minus sine quantity squared. And we'll multiply out the 1 minus sine, and we see that we have a sine squared plus cos squared, which is the equivalent of 1, so the two 1's can be combined into 2 minus 2 sine, and we can take out a 2, so it's 2 times 1 minus sine. The 1 minus sine cancels in the numerator and denominator, leaving you with 2 over cos, which is the equivalent of 2 secant, and you get your answer. In this problem, the left side is more complicated, so we'll separate sines and cosines, and then get rid of a fraction within a fraction by multiplying the numerator by the reciprocal of the denominator, and you're left with sine over cos plus sine over cos, which is 2 sine over cos, which is actually 2 tan. In this problem, each side is equally ugly, so we'll start on the left as has been the pattern in this video. So we'll separate the sines and cosines and then get rid of the inner fraction by multiplying by sine over sine, and that becomes 1 minus sine over cos. And then as we did in the first problem of this video, we'll multiply the numerator and the denominator by the denominator of the desired result. And then multiplying that together, we get this. And you can see that with sine times cosecant, that's actually just 1. And that 1 is negative, so it cancels with the plus 1. So you're left with cosecant minus sine in the numerator. We will separate the sines and cosines in the numerator only because we want that cosecant plus 1 in the denominator for the final answer. Next, we will multiply the numerator by sine over sine in order to get a common denominator of sine in the numerator for that inner fraction. Can combine those to 1 minus sine squared, which becomes cos squared, and the cos's cancel, and cos over sine is cotan, so it just becomes cotan over cosecant plus 1. In this problem, we are going to start on the left side, even though it may appear that the right side could be more complicated, but they're about the same. So for this, we will multiply the side by cotan over cotan, which combined it's cotan plus cotan times tan, and then cotan minus tan times cotan. And tan times cotan, since they are reciprocals of each other, are just 1, so you get cotan plus 1 over cotan minus 1. In our final problem, the right side is more complicated. So first we will separate the cosines and sines. We'll see that they have a common denominator of cos, so you can combine them, and then separate the squared, so you can see that you have a cos squared separately in the denominator, and a 1 minus sine quantity squared in the numerator, which can be so then we want to see that cos squared is equal to 1 minus sine squared in the denominator, which factored out is 1 plus sine times 1 minus sine. The 1 minus sines cancel, and you get your answer of 1 minus sine over 1 plus sine. Thanks for watching.